In this video, we are going to discuss about Cisco Packet Tracer. The content of this lecture is objective, introduction, and there are 8 experiments we are going to discuss in this video. At the end of this video, you can able to implement a simple network in Cisco Packet Tracer. The objective of studying this Cisco packet tracer is to make the students to learn the principles of networking with hands-on experience as well as develop the Cisco technology specific skills. That is in your classroom you have studied technical concepts, that is theory, and some of the networking systems you have learned, but in this Cisco packet tracer you are going to implement those technical concepts which you have learned in theory classes. You are going to practically implement with this Cisco packet tracer, and this helps the students to complete the assignments. The name suggests that it is a tool built by Cisco. It is a network simulation software which will helpful for practicing simple as well as complex networks. As a student, you are going to implement or you are going to design some of the basic network, simple network with this CPT. But as an network engineer, they can able to design a complex network with this Cisco packet tracer. And again, the engineers who would like to deploy any changes in the production network prefer to use this Cisco packet tracer because they are going to test the required changes, and once it is successful they can deploy it in a real life. This makes the job easier for engineers, allowing them to add or remove the simulated network devices. That is, if you're having 4 switches and 2 routers, you can able to remove one of the router and check whether it is working or not. And if you want to add server, you can add it. If you want to add any other network devices or end devices, you can add and check whether it is properly working or not. And after that, you can implement in a real time scenario. This is a basic thing in CPT. Next, we will move on to the first experiment, that is connection between two computers. To do this experiment, you need two PC, that is PC 0 and PC 1, and you need one cable. This is a simple basic experiment. To do this, you need a Cisco packet tracer. At the end of the video, I will explain how to install CPT. Just open the Cisco packet tracer. Wait for a second. So this is nothing but the Cisco packet tracer software. You can see here this is a layout. In top you can see there are menus like file, edit, options, view, tools, extension, window, etc. And in the bottom of this software you can able to see there are so many network devices available. So see here, this is router, switches and hubs, and so many network devices, that is intermediary nodes available here. And this is end device, that is PC, laptop, server, printer, Vivo IP, TV, smartphone, everything is available here. And see here, this is a cable. You can see there are variety of cable available. So the first one is automatically choose the connection type, auto connect cable. And see here, this is console and this is copper straight through cable, this is copper crossover cable, and this is fiber. And many cable available, you can choose whatever you want. So first experiment, connection between two computers. So I need two PCs. Go to this and click and drag it, just click and drag it. Okay, the next I need a cable. I'm using auto connect cable which automatically choose the type of connection. So I'm going to click and just drop it. Then next I need an important thing, that is to set an IP address. An IP address is used to identify the host. If I want to send a message from one PC to another PC, I need IP address of the receiver. So I'm going to set the IP address. To do that, click PC 0 and go to desktop and IP configuration. And in this IPv4 address, just click 192.168.1.1. You can type any IP address as you want and just close it, and do this for PC 1 as well. 1.2. close it. And to test the connection you need a message, right? So to enable or to insert the message, just see at the top of the screen, add simple PDU. So just click it and place it on both PC0 and PC1. Okay, so why I am placing both PC0 and PC1 is, PC0 is going to send a message to PC1, PC1 is going to send an acknowledgement to PC0. To simulate, just see at the bottom simulation and click this run button. You can see the PC0 is sending the message to PC1, PC1 is sending acknowledgement to PC0. It shows the tick mark, that is the message is sent successfully. See here at the bottom there is a status called a successful, source PC0 and destination PC1 using ICMP protocol. You can see here the next experiment is, you can save it by clicking file, save as, like that you can save. The next experiment is star topology. What is meant by star topology? All the network devices are connected to the centralized node, that is hub or switch. So I'm having three PCs. All the three PCs are connected to the central node, that is switch. If PC0 wants to send the message to PC2 means it will not directly send the message to PC2. As I already told, see here there are PC0 and PC1. If I want to send the message from PC0 PC1, it will directly send. But in this star topology, all your nodes are connected to the central node, that is switch or hub. So if you want to send from PC0 to PC2, first of all the PC0 will send the message to switch and the switch will pass the message to PC2 and as PC1 as well. So it will send the message to all the nodes, but other node will reject the packets or reject the message. Only the intended receiver will accept that message. This is the concept behind star topology. Now let us do this experiment. Just click file new. If you want to save, you can save. I need three PCs. You can add a more number of PCs. And I need a switch. Okay. Then next I am going to connect auto connect cable from PC0 PC to switch. Okay. So after connecting, we need to set an IP address. If you find if the video is slow, you can speed up the video and you can see it. Okay, I set the IP address for all the three computers. After that, if you want to test the connection, that is if I'm going to send the message from PC0 to PC2, I want to know whether the PC2 is available, whether the PC2 is in connection or not. You can test it by just clicking the PC0 and command prompt, type the command ping. The ping command is used to check whether the connection is available or not, whether I'm going to whether I can able to communicate with the receiver or not. Ping command and then type the IP address of the intended receiver, 192.168.1.3. This is the IP address of PC2 which I want to communicate. Just click enter. You can see I am getting reply from the PC2 computer. So the connection is available. Just click and drag the PDU PC0. I'm going to place it on PC0 and PC2 as well. And I'm going to simulate. Just click the simulation and run button. PC0 is sending the message to switch 0, that is centralized node, and it sends a message to PC2. Now this PC2 is sending acknowledgement to the switch 0 and switch 0 is sending that acknowledgement to PC0. Now the connection is message transferred successfully. Then next experiment, connection between two switches. That is, in a previous experiment we have seen that there are only one LAN, that is three computers and one switch. In this third experiment, there are two LAN 1 and LAN 2. LAN 1 is having switch 0 and LAN 2 is having switch 1. These two LANs are connected with the help of copper crossover cable. I simply keep this aside. If you want to delete this scenario, that is sending the message, you want to delete means just see here the scenario 0 at the bottom of the screen and click delete so that the message will delete. I need another two computer for LAN 2. Just click and drag it. And one more switch I need. Okay. The next two auto connect cable and one copper crossover cable. When you click, it shows the port number gigabit Ethernet 0 bar 1. And when you click with switch 1, gigabit Ethernet 0 bar 2. Just click it, that is port number. Then next, if I want to, this is a LAN 1. Switch 0 is having three computers, LAN 1, and LAN 2 is having two computer, PC3, PC4, and a switch. So I'm going to test from LAN 1 to LAN 2. That is, I'm going to transfer the message from PC1 to PC4, and I'm going to check whether the PC4 is available or not. Before checking that, I need to set an IP address for LAN 2. I set IP address for LAN 1 in previous experiment. For PC3, I'm going to set IP address as 172. As because these are computers in LAN 2, different location, and so that I need to change the IP address as 172 range 1.1. 172.168.1.2. Okay, now I'm going to check from PC1 whether the connection is available with PC4 or not. Just click PC1 and click command prompt. I'm going to ping the IP address 172.168.1.2, which is IP address of PC4. It is checking whether the connection is available, PC4 is available or not. Wait for a while. See here, it shows the request timed out. That is, I am sending four packets, but the loss is four. I didn't receive any packets. That is, PC4 didn't get any packets, so that it indicates the PC4 is not available right now. The connection is not available. So I'm going to send the data from PC1 to PC3. So just check whether the PC3 is available or not by clicking ping 172.168.1.1. This is a PC3 computer IP address. Wait for a while. So if you get a reply like this, it indicates the connection is available. You can send a message to the intended receiver. When you get a message like a request timed out, this indicate the connection is not available. Wait for a second until unless you get the message. Sorry, actually, the IP address I have entered is wrong. PC0, I set IP address 192.168.1.10, like that range. For a PC3 and PC4, I have entered 172, but change that one. Just enter 192.168.1.50. I'm going to set 50. The 192 range I'm going to set, and for PC4, IP config 192.168. 1.51. Okay. After setting the IP address, I'm going to check whether the connection is available or not. Ping 192.168.1.50. That is PC3 computer. You are getting a reply from this PC3 computer. So you can send message from PC1 to PC3. Just click this PDU and place it on both PC1 and PC3 simulation, and then click this run button. The PC1 is sending message to switch 0. Switch 0 is sending message to switch 1. Switch 1 is sending to both PC3 and PC4. The PC3 is sending acknowledgement to switch 1, and switch 1 is sending acknowledgement to switch 0. Switch 0 is sending acknowledgement to PC1. So your data transmission is successful. See here, when I click that PDU from PC1 to PC3, it's automatically click the PDU for PC0 as well. See here at the bottom of the screen, it shows the first data transfer is from source PC0 and destination PC3. It's actually wrongly automatically placed that PDU in PC0. The status is failed, but we have placed the PDU in PC1, the message in PC1 to PC3. That is successful. We can also check another scenario. Just click this PDU and I'm going to place it on PC2 and PC4, and then click simulation and run button. PC2 is sending message to switch 0. Switch 0 is sending message to switch 1, and as well PC0 to PC1. But these two computers reject those message because it is not an intended receiver. PC3 is also rejecting. Only PC4 is accepting the message because it is an destination. And it send the acknowledgement to switch 0. Switch 0 is going to send the acknowledgement to PC2. Your data transmission is successful. Okay. The next experiment is connecting two networks using router. You are going to connect the two network in different IP address. That is this network LAN 1 is having 192.168.1.1 on that range IP address, and in the LAN 2 it's having 172 range. The router is going to connect the switch 2 and switch 1. To do this, click on the Cisco packet tracer, and I'm going to use the same PCs for the another experiment as well. Just click file and new. You need three PCs for LAN 1, and three PCs for LAN 2, or otherwise two PC you can use. And you need a switch. You need a router. After that, as usual, you can connect auto connect cable, and you need a copper crossover cable for connecting the two switches. But in this experiment you are having router, so you don't need copper crossover cable. You just connect the switch with the router using copper straight through cable. Here it is a copper straight through cable. Just click and fast ethernet 3 bar 1, gigabyte ethernet 0 bar 0, 2 bar 1, and click 0 bar 1. You can see the red color arrow mark shows that the connection is not actually successfully done. See here, in this auto connect cable, you can able to see the green color arrow mark. It shows that the connection between PC and switch is successfully done. But this red mark shows your connection is not actually successfully done. So to do that, just click router and config. You can see gigabit ethernet 0 bar 1. Actually this is placed in gigabit ethernet 0 bar 0. So just click this gigabit ethernet 0 bar 0, and your port status is actually not in an on condition. So enable the on button and just close it. Now you can able to see the green color arrow mark. Same thing do for gigabit ethernet 0 bar 1. Click on and you can able to see the green color arrow mark, which shows that the connection is actually successfully done. And after that, you have to set an IP address for all the PCs. Just go to desktop IP config and IPv4 address 192.168.1.1, 192.168.1.2, 192.168.1.3. And after that, for PC3, I'm going to set the IP address as 172.168.1.1. And here 172.168.1.2, because these are the computers in different locations, so you have to set a different IP address. Whereas in previous experiment, all the two networks are in same location, so you have to set an IP address as a 192 range or 172 range, the same range you have to set. In this condition, we are using router, so different locations, so you have to set a different range for the IP address for LAN 1 as well as LAN 2. After that, you need to set IP address for router as well. So router 0, then gigabit ethernet 0 bar 0, and click IPv4 address. So this is a gateway actually. Gigabit ethernet 0 bar 0, I'm going to set IPv4 address 192.168.1.100. And after that, for a gigabit ethernet 0 bar 1, because this is the port in which the switch 1 is connected, 172.168.1.100. See here, don't confuse it. The router 0 is having two port, gigabit ethernet 0 bar 0, 0 bar 1. We didn't use that 0 bar 2, only we are using 0 bar 0 and 0 bar 1. The switch 1 is connected. See here, we are using copper straight through cable. The switch 0 is connected with the router 0. The port number the port number is gigabit ethernet 0 bar 0. So that only I'm setting IP address for 0 bar 0 as 192 range, and 0 bar 1 is connected with switch 1. Switch 1 is having IP address range 172. And after that, you need to set a default gateway config and see here, desktop IP configuration. You have to set the default gateway. So default gateway is nothing but, if you want to send the message from PC0 to PC3, first of all, it need to cross the 172.168.1.100, so that it can able to reach the PC3. So that for all the computers in LAN 1, you have to set the default gateway as 172.168.1.100. And if you want to send any message from LAN 2 to LAN 1, that is PC3 to PC1, means you have to cross this route, that is this 192 range IP address, so that it can able to transfer the message to PC1. So now just click PC0 on IP config and set the default gateway as 172.168.1.100. Set for all PCs ipconfig default gateway 172.168.1.100. Same thing do for PC3. PC3 default gateway is 192. Okay, after setting all the gateways, just check whether the PC3 is available. PC3 IP address is 172.168.1.1. Just I'm going to send the message from PC1 to PC3. So to test the connection, just click command prompt ping 172.168.1.1. Wait for a second. Request timed out, and there is a reply also. Received the three last one. Okay, connection is available. So just drag the PDU and place it on PC1 and PC3, and just click simulation and run button. PC1 is transferring the data to switch 0. Switch 0 is going to transfer the data to router 0, and it should pass the gateway, that is 172 range gateway, to reach switch 1. Switch 1 is going to send the data to PC3. After accepting the message, it sends an acknowledgement to switch 1. Switch 1 is sending acknowledgement to router 0, and router 0 is sending acknowledgement to switch 0. Switch 0 is sending acknowledgement to PC1. Successful. You can see the status at the bottom of the screen. Okay. The next we will do another experiment, wireless connection. So in last four experiments, we have seen all the nodes are connected using a cable, that is copper crossover cable for connecting two switches, and copper straight through cable for connecting switch and router, and we use the auto connect cable to connect the PCs. But in wireless connection, how it's going to work, that's what we are going to see in this experiment. Just go to the CPT. To do this experiment, I need access point, that is Wi-Fi, and one PC, laptop, and smartphone. Just click file new. If you want to save, you can save. And I'm going to use a PC and laptop, and then smartphone. After that, I need access point, APPT, which is nothing but access point. You can see the mobile phone is smartphone is automatically connected with the Wi-Fi. As because I didn't set any password or username for Wi-Fi, to do that, just click access point and go to config, and just click port 1, and you can see the SSID here. The SSID is in default. You can set the SSID is nothing but username of your Wi-Fi. I'm going to set SSID as ECE, and to set password, just click WPA2 PSK, and password I'm going to set as third year. Okay, so I set password, username and password. Now you can able to see the connection is actually dropped because I set username and password. If you want to access Wi-Fi, you need to enable. You need to set the IP address and password for your sorry, not an IP address. You need to insert a password in your smartphone. Just click the smartphone and desktop. One second. Click the smartphone and see wireless 0, and SSID is ECE. Click ECE, and click on WPA to PSK, and password is third year. Okay, after that, wait for a while to connect the smartphone with the PC. Now you can see a smartphone is now connected with the Wi-Fi. And to connect this PC0 and laptop with the access point, that is Wi-Fi, you need to do some procedure. See here, this is a CPU, and you have to turn off CPU. Just click this red button, and scroll on. You can able to see this is a wired mode. That is wired module. Just click and drag it and place it on here. Remove that wired module, and click this WMP300N and place it on this. This is a wireless module. To access a Wi-Fi, you need a wireless module. Just click and drag it, and now you can turn on the CPU. Then go to desktop. Then click PC wireless. Wait for a while. You can able to see the Wi-Fi and password here. See the easy, which is a Wi-Fi name. Just click on and connect. It asks password. Your password is third year. Connect. Click connect. Now see your PC is actually connected with the Wi-Fi. And same procedure for laptop. Just turn off this laptop. You can see the yellow color light is in a off condition. And remove this module. Just click and drag it. And place this WPC300N, which is a wireless module. Then go to desktop and PC wireless. Sorry, the device must be powered on. Just switch on the laptop and click desktop, PC wireless, and go to this connect. Wait for a second, it will show the Wi-Fi, the ECE, which is your Wi-Fi name available right now, and click connect. You can enter the password now, third year, and I just click connect. Now the laptop is connected with the Wi-Fi. Now all these three nodes are wirelessly connected. And one thing you have to note, this is a logical layout. At the top of the screen, that is top of the Cisco packet tracer, you can see there are two layouts. One is logical mode and another one is physical mode. The logical mode, you can see only the network devices and the connection. But in physical mode, you can able to see the building where your network is there, and you can able to change the building or change the table where your node is actually placed. See here, I am clicking the physical mode. You can able to see this is a home city in which your network is actually there. Now zoom it off. When I double click, it shows the corporate office, and when I double click, it shows actually where your PC, laptop, and smartphone is there. See here, this is a main wiring closet. You can drag that smartphone on the table, and laptop on any other place wherever you want. So another thing you have to note is that you can able to see the purple color. In some region the purple color is more, in some region you can able to see the white color. Actually the purple color indicates the signal strength. You are using Wi-Fi, right? So the signal where the strength is high, it indicates a purple color a lot, and where the signal strength is low, it shows a white color. In top of the screen you can see many objects are there. Create a new rack. If you want to create a new rack, just click it on and drag it. This is a new rack. If you want to place it on any place, you can just drag and drop. The next, this is a new city, new home. This is a physical mode actually. This is a logical mode where you can see only the node and where you can see only the node and cables. In physical mode you can see the buildings and where your laptop or your node has been located. So now you can check the connection by just click the PDU, and I'm going to transfer the message from PC0 to smartphone. Just simulate. PC0 is transferring the message to access point. Actually still is in progress. You can see the status here in progress. Your intended receiver is smartphone, right? So the PC0 and laptop is rejecting the messages. The smartphone is actually received the message. It sends an acknowledgement to access point. The access point is sending the acknowledgement to all the devices actually, but the PC0 is only accept, remaining or reject that acknowledgement. You can see the status at the bottom. Now we can move on to the another experiment, that is simulate DHCP. What is meant by DHCP? DHCP is nothing but dynamic host configuration protocol. In last five experiments, actually we manually allocate the IP address for all the nodes. Say for example, if you are having a five computer in your network, it is possible to manually allocate the IP address to your PCs. If you consider a scenario where there are thousands of computer or hundreds of computer in your network, you cannot able to manually allocate the IP address for each of the computers or each of the nodes. So to easily access or easily allocate the IP address to your nodes, you need a protocol called DHCP, that is Dynamic Host Configuration Protocol, which actually allocate the IP address automatically to all the nodes in your network. You have to set the range what you want, and you have to set the starting IP address. After setting these things, it will automatically allocate the IP address for all of the computers in your network. In this experiment, I'm using three PCs and one switch and one server. Just go to CPT and click new, and I need three PCs, the same procedure as we did earlier, and you need a switch and you need a server. Okay, now I'm not going to allocate the IP address for all these three PC. Just I'm going to assign the IP address for server. The server will automatically assign the IP address for all these three computers. So I'm going to change this server name as DHCP because it's going to do the duty of DHCP. Just I'm going to connect the switch to the server with the auto connect cable and click the DHCP and click on the services and click on DHCP. Just on this service because you are going to use the DHCP. Then next, what you are going to do is, before setting these things, you have to assign the IP address for DHCP. So to do that, go to desktop and IP config, and I'm going to set the IP address for this server as 192.168.1.100. Don't think that I'm manually entering the IP address. I'm setting IP address only for a DHCP server. For server only, I'm going to manually enter the IP address. For remaining PCs, it will automatically allocate it. We will see later on. Just close this window and go to services, DHCP. See here, it asks starting IP address. So I'm going to set the starting IP address is 10. The next click add. Okay. Now after that, close this DHCP, then go to PC0, desktop, IP config, and enable this DHCP option. It will automatically allocate the IPv4 address. See here, the DHCP request successful. I didn't enter any IP address for this PC. It will automatically assign the IP address 192.168.1.1 to the PC0. Same thing do for PC1. Just click PC1, desktop, IP config. See here, this is in static mode. In static mode, you should manually enter the IP address. I'm enabling DHCP. See here, it requests IP address on the server. It's automatically allocate 192.168.1.2. Same thing for PC2. Desktop IP address DHCP 1.3. You just actually enter the IP address 192.168.1. It will automatically allocate the IP address for all the PCs. Okay, the next experiment is simulate FTP. FTP is nothing but file transfer protocol. You are going to transfer the file. In a normal scenario, if you are having two computers or three computer, if I want to transfer the file from PC0 to PC1, I need a file from PC0, and PC0 will say, for example, if I'm having demo.txt file, I want to send from PC0 to PC1. I sent PC0 demo.txt to PC1. If I'm going to transfer the same demo.txt to PC3, I need a help of PC0 because that file is in PC0 only. Instead of doing that, I'm going to use an FTP server, that is file transfer protocol. If I want any file, I can access the file with the help of the FTP server. So we will do the experiment. You can able to understand it clearly. To do that, I need a two server and two PC and one switch. See here, file new. I need a two PC and two server and one switch. I'm going to connect all these with the auto connect cable. Actually, this server is not actually need. We can delete it, or otherwise we can keep it. Say for example, I'm using DHCP server here, and this is a server FTP file transfer protocol. The DHCP, you already know why we need DHCP. Just go to config desktop IP config. I'm setting DHCP IP address is 192.168.1.100. Okay, after that, go to services, enable DHCP, and starting IP addresses. Actually, it's 192.168.1.0. We will keep it as it is. And FTP IP address is config 192.168.1.200. I'm going to set as 200. And for PC1, PC0, I am not going to manually enter it. Just enable the DHCP. Successful. Then next, here as well, enable the DHCP. Okay, done. Then next, this is a file transfer protocol. What I'm going to do is, I'm going to transfer the file from PC0 to PC1. Not directly. I'm going to write my file, that is any file from PC0 to FTP server. This FTP, with the help of this FTP server, PC1 can able to access it. See, actually, if I am going to transfer a file from PC0 to PC1, I didn't need any FTP server. But what I'm going to do is, I'm going to insert my file in the FTP server. If any computer wants to access that file, it access the file with the help of the FTP server. Click on the FTP server and services. Enable the FTP. The FTP is actually non condition. You have to set the username and password so that any PC can access the FTP. I'm going to set ECE and password as third year. See here, there are four options, five options: write, read, delete, rename, list. These are all the options. You can use it for your file. If you want to write any data in your file, you can write. You can read any data, you can read or delete, rename, list. I'm enabling only these two options, write and read, and just click add. See here, your username and password, and what is the permission the FTP server is providing is only read and write. Okay. See here, the file. There are so many files here. Now I'm going to make a file that is demo.txt. To do that, I'm going to click the PC0 and see here the text editor. Here the file. I'm going to set a new file. Welcome to Cisco packet tracer. So I'm typing one text and I'm going to save it. File, save. I'm saving this file as demo.txt. Click OK. Now you can see there are two files available here. One is sample file.txt, which is not created by us. We created demo.txt file where there is a text called welcome Cisco packet tracer is there. Now this demo.txt file is in PC0. I am going to put this file in server so that any computer can access with the help of FTP. To do that, just click PC0 and click command prompt and enter FTP. IP address of the FTP server is 192.168.1.200. Just click enter. It asks username and password. What is your username? ECE and password. If you type password, it will not show actually is a password. Just enter and enter your password and click enter. Logged in. Then next, you have to put the demo.txt file in the server. To do that, just click put demo.txt. This is a command to put your file in the FTP server. Just click enter. See here the transfer complete. Now when you click FTP server and click FTP, see here your file is actually there, demo.txt. In previous we have seen the demo.txt is not in the FTP server. Now it's available in FTP. Okay, now I'm going to access that demo.txt file from the server in PC1. Actually, in PC1, click PC1, text editor, file, open. You can see only the sample file.txt file is there. I want to access the demo.txt file without the help of PC0, but I need the demo.txt file. How can I able to access it with the help of FTP server? To do that, click PC1, command prompt, FTP 192.168.1.200 and click enter. Username is CCE and password is third year and click enter. And you need that file demo.txt from the FTP server. So just click get demo.txt. Click enter. Now you can see in the PC1 text editor file open. See here the file is there. Previously, PC1 didn't have that file demo.txt, but with the help of FTP server, it accessed it. With the help of username and password of the FTP server, it accessed the demo.txt file from the server. Where it is useful means when your network is having thousands of computer, you don't need to ask the source to get the file. Say for example, if I'm having 100 computer here, PC0, PC1, PC2, PC3, etc. up to PC100. If a PC100 is 100 want to access the data from PC0, it can able to access. If PC99 is also wants that data, it need the help of PC0. Instead of doing that, if I insert my text file or any file in the FTP server, any user can access that file at any time with the help of the FTP server when you know the username and password. Okay, then next we will move on to the another experiment. I hope you have understood the concepts. If any doubt, you can ask in comment. Next experiment we are going to see is HTTP, that is Hypertext Transfer Protocol. To do this, you need one switch and four server and then three PCs. Go to Cisco Packet Tracer and click and drag three PCs, and you need a four server. I will tell you why we need four server, and you need a switch. Okay. After that, you need auto connect cable to connect the server with switch. Okay. So this server is a DHCP server. You already know what DHCP will do. It automatically allocate the IP address for all the computers, and you need a DNS server. DNS is nothing but domain name system, in which it contains the list of domain names and its IP address. For example, if you are using google.com, yahoo.com, many websites are available. So this DNS purpose is it consists of list of websites, list of name and domain name and its IP address. Say for example, if you're having Google, its IP address will be stored in the DNS server, as well as yahoo.com and its IP address, and so many websites, the domain name and its IP address will be stored in the DNS server. The next server is I'm using google.com. You can use any website name as you want, and I'm using amazon.com. Okay, then after that, you have to set IP address for the servers. You have to allocate manually for all the servers, but for PCs it will automatically allocate the IP address using the DHCP protocol. Now click the DHCP server and go to desktop and IP config. Set the IPv4 address for DHCP server is 192.168.1.1. Okay. The next I'm going to set the IP address for DNS as 192.168.1.2. Then for Google, I'm going to set IP address is 1.3. Then for Amazon, okay. After setting, what you have to do is you have to click the DHCP and go to the service, then enable this DHCP option, and you have to enter the DNS server IP address 192.168.1.2. The next, you can assign the starting IP addresses 10 and then click save. Okay, it's saved. The next, you have to assign the IP address for PC by enabling the DHCP option. Just click IP config and enable DHCP. It automatically assign. See here the starting address, as we mentioned, 10. The next, you have to do the same procedure for all the PCs. Okay. The next, what you have to do is just click on the DNS server. As I already said, the DNS server consists of list of domain name and its IP address. So you have to enter that one. So just click the DNS and enable the DNS server as on, and the name of the domain name is www.google.com, and its IP address we have entered as 192.168.1.3. Just click add. The next, another domain name is amazon.com, www.amazon.com, and its IP address is 192.168.1.4. Okay, just click add. See here at the bottom, the two domain name and its IP address is shown here. The DNS server saves its domain name and its IP address. When you type the URL in your PC, it will automatically request the DNS server for its IP address, and it will open the web page. This is the concept behind that. So in Google server, Google, you have to enable the HTTP service. So see here, it is in an on condition. Here, index.html page. When you type google.com, this page will be get open. Just click edit and see here, this is a HTML commands. If you know the HTML command, it will be better. If you don't know also, just follow my commands. That is, I'm going to change only this Cisco packet tracer into welcome to google.com. For demo purpose, I'm using simple commands like welcome to google.com. Welcome to Google. You can change these as well, but simply I'm going to change only this welcome to Google, and click save. Click yes. Then next, for Amazon, do the same procedure. Click service, enable this HTTP, and click edit, and change this one as welcome to Amazon. Click save and yes. Okay, now you can check by, I'm going to check with this PC1. Just click PC1 and I'm going to use a web browser. Just double click it. Now we enter the URL like you are using in laptop, you enter www.google.com. Like this, I'm going to enter it www.google.com and just click go. Wait for a while. It's not get open. Just click another URL. Go. Okay. In DHCP, turn off all the other services. Only the DHCP server should be in on condition. Turn off all the other protocols. Make sure that other protocols are in off condition, because it get confused when you turn on all the other protocols. Okay, only DHCP is in on condition. Then next, go to DNS server and make sure that DNS server is only in on condition. Turn off all the other services. Okay, now we will check whether it is now available. Just click on the PC and click web browser. Click the web browser. Wait for a second. I'm going to type www.amazon.com. Here the Amazon web page get open. The next I'm going to check for Google as well. Welcome to Google. The Google web page will get open. You can check with any PCs as you want, desktop and web browser. And then I'm going to check www.google.com. The web page will get open. So this is nothing but HTTP, that is hypertext transfer protocol. To do this, you need a DNS server to store all the domain name and its IP address, and you need a DHCP server for allocating IP address, and you need Google and Amazon and many servers for a website. Thank you.